Okay, plan for this recording is to look at graphing functions. More specifically, looking at graphing these three particular functions. Linear, quadratic, absolute value. Not going to spend much time on linear because we did that in another course. We'll graph mainly quadratics and absolute values. However, we will touch on the linear just to refresh our memory. Okay? So that's kind of the plan. So let's grab an XY axis here. And let's graph y equals 3x plus 2. Thinking back to y equals mx plus b, my b is my y-intercept. So 2 is my y-intercept. M is my slope. So 3 is my slope. Remember what slope means. Rise over run. How far up and how far do I go from one point to get to the next point? If you think about graphing, that's impossible if I don't have a starting point. I can't go up and over from a point if I don't have a point to go from. That should make sense. So when I think about what do I graph first, do I graph my slope or do I graph my y-intercept? It should make sense that you have to graph the y-intercept first. Otherwise, you have no idea where to start when you start counting your slope. So my first step is to graph the y-intercept. Y-intercept. This is my y-axis. Positive 2 is the y-intercept because this number right here is a positive 2. Okay. Remember or notice slope is a fraction. It's rise over run. So 3 as a fraction is 3 over 1. That tells me from 2 I count up 1, 2, 3 and over 1. I can do that again, 1, 2, 3 and over 1, and I can keep doing it as many times as I want. I could also, and this is just for good thinking skills, I could also treat that as a negative over a negative, because a negative divided by a negative is a positive. So I could come down 3 and over 1 also as many times as I would like, and I can connect those dots. They should all line up on a nice, neat, straight line, and we have it. There's a graph of y equals 3x plus 2. All right? Should be able to go backwards. So if I give you an equation, if I give you a graph, and I tell you to write me the equation, or your textbook asks you to write the equation of that line, what would you put? Again, remember, at any point in time, you hit pause so that you can try the problem before I explain it. Think about your equation and how we just graphed that last problem. I need to fill in for my m, and I need to fill in for my b. What is my slope and what is my y-intercept? Doesn't matter in this case which one you do first. I look at that, and I see a y-intercept of a negative 3. So I'm going to put a minus 3 out here. Starting from there, how far do I have to count up and over to get to another point? Well, that's not totally fair because there's an infinite number of points on that line. So let me describe that a little more precisely. How far do I have to go up and over to get to another whole number xy coordinate? Well, every time these grid lines intersect, those are integer coordinates. So this one here is at a negative, positive, 2, negative 2, right? So how far do I have to go up and over to get to that point? Same as this point, same as that point. I'm going up something and over something. Looks like up 1 and over 2. Yep, up 1, over 2, up 1, over 2. My slope is a half. Okay? Linear equations. That's about all the time I'm going to spend on that one because that should be a lot of review. Let's go to the new ones. Think back to whenever it was which is before this course, where did you learn how to graph linear equations? Where did you learn how to graph? We learned, not where. How did we learn how to graph? We learned how to graph by making tables. So let's look at y equals x squared. This is called a quadratic. It is not linear. It's not a straight line. It gives the shape of what's called a parabola, which I'll show you once we graph this thing. But when we started graphing a linear equation, we made tables. Hopefully you made tables in whatever course you learned it in. So let's just do that. Let's just make a table. And let's just start picking x coordinates. Let's plug them in and see what y comes out to be. So let's just say I plug in a -1. When x is a -1, a -1 times a -1 is a +1. Let's go further back. What if x is a -2? A -2 times a -2 is a +4. When x is 0, 0 squared is 0. 1, 1 squared is 1. 2, 2 squared is 4. I'm going to rearrange these just for ease of writing. We'll make that a -1, -2. Notice a pattern there. And it should be an obvious pattern. Whatever x is, you square it and you've got y. Well, that makes sense because it says y is equal to x squared. Okay, but sometimes we don't make a connection between our table and our equation, and what our equation really tells me is a relationship between 2 points. Whatever you do to the x, you have to square it, and that's what you do to the y. So if I go out one more, if x is 3, y would be 9, and so on. Okay? So now let's graph this thing. When x is 0, y is 0. When x is 1 or -1, y is 1. When x is 2 or a -2, y is 4. When x is 3 or a -3, y is 9, and so on. And we get this shape, which is kind of like a U, but it's not. It's a parabola. And it goes forever on both ends. A parabola. In case you can't quite hear what I'm saying. A parabola. Okay? That is a basic y equals x squared graph. Now, what if I gave you y equals x squared plus 3? What do you think that plus 3 will do to the graph of y equals squared? Or another way of saying it, how is y equals x squared plus 3 different than y equals x squared? If we're not sure, let's just make another table. Let's use the same x values so that we can make some quick and easy comparisons. If I plug a -2 in here, -2 squared is 4, plus 3 is now 7. Plug a -1 in here. -1 squared is 1, plus 3 is 4. Plug in a 0. 0 squared is 0, plus 3 is 3. You should see the pattern. It simply added 3 to every single y value. What does that do to my graph? It simply moves it up 3. When x is 0, y is 3. When x is 1 or a -1, y is 4. When x is 2 or a -2, y is 7. And I get the exact same graph, but moved up 3. Same shape, but what I really did is I just took this blue graph and I shifted it up 3. That's all that happened. Okay, so that should not be a problem. Here's an interesting one. What if I did this? What if we change that to y equals x minus 2, and I put it on the inside? Notice before it was on the outside. It was x squared plus something. What if I stick it on the inside? Well, once again, we don't know what it does. Let's pick the same values. negative 2, negative 1, 0, 1, 2. When x is a negative 2, now I put it here. A negative 2 minus 2 is a negative 4. So now I have a negative 4 inside parentheses that's being squared. Everyone see that? I put a negative 2 in for x. Negative 2 minus 2 is a negative 4. And I square negative 4 means a negative 4 times a negative 4, I get 16. Wow, that's not even close to what we had before. Well, let's just keep going, see if we can see a pattern. So now I'm going to put a negative 3 in here. Sorry, negative 1. And I get a negative 3, right? Negative 1 minus 2 is a negative 3. Negative 3 times a negative 3 is 9. Oh, I see a 9 down here. Maybe we're getting close. Let's change it again. Let's put in 0. 0 minus 2 is a negative 2. A negative 2 squared is 4. Okay, starting to look familiar. Plug in a 1. 1 minus 2 is a negative 1. And a negative 1 squared is a positive 1. Now we're definitely starting to look familiar. Plug in 2. 2 minus 2 is 0. 0 squared is not 4. 0 squared is 0. Okay, that looks familiar. I hope you're asking the same question I'm asking. What happens on the other side of 0? I've gotten these values up here. Will I get these values down here? Ever? Well, let's try. Let's try 3. 3 minus 2 is 1. 1 squared is 1. So, yep, that worked. We got 1. And when we plug in 4, 4 minus 2 is 2. 2 squared is 4. I'll get rid of my pen icon there. Whoops, it went away on its own. Okay, so this is a 4. All right, let's plot those points. I'm going to start right here because that is where this pattern and this pattern are the same. It goes 0, 1. As I go this way, it's 0, 1, 4. It goes this way, 0, 1, 4, just like my other one. So when x is 2 now, I'll do that in green. When x is 2, y is 0. When x is 1, y is 1. When x is 2, y is... sorry, I said that wrong. When x is 1, y is 1. When x is 3, y is 1. When x is 4, y is 4. When x is 0, y is 4. Notice it's the same shape as before. It's just like that blue graph, but it's that blue graph now shifted to the right 4, or sorry, right 2. Huh. This says x minus 2. But what it really did was moved to the right 2. That is always the case. When it is inside the square, when it's hooked to the x value, it does do the opposite of what it looks like. X minus 2 actually really does move my graph to the right 2. Why? In order for my x value to be 0 like it is here, because of me subtracting 2 from the x's before we square it, we have to input values that are 2 numbers bigger than what it was in this other graph. So when x is 0, 0 squared is 0. Well, how do I make this expression here a 0 so I can get the exact same y value as I did in the original first graph? I put in a number 2. I put in something that's 2 units bigger because I have to subtract 2 first. Okay, let's stick with those 2 concepts and let's practice. Your turn, sorry. Sketch a graph of that. All right, so here's what I got. I'm going to make a table, but I'm going to quit making tables very soon here. Where do I want to start? Well, if I look at that and I see x plus 3, knowing what I just explained, I know that I want to know what makes that inside 0. What makes that inside 0? A negative 3. So my first number I kind of want to look at is a negative 3. If I put a negative 3 in for x, a negative 3 plus 3 is 0, and 0 squared is 0. One more time in the logic. My goal is to ask the question, what makes this piece 0, and start there. Now, as I move up and down from there, my pattern should follow that same 1, 4, 9, etc. Does it? Put a negative 4 in for x. Negative 4 plus 3 is a negative 1, and a negative 1 squared is a positive 1. Put in a negative 2 for x. Negative 2 plus 3 is 1. 1 squared is 1. Put in a negative 5. Negative 5 plus 3 is a negative 2, and a negative 2 squared is 4. Put in a negative 1. Negative 1 plus 3 is 2. 2 squared is 4. It does have the same pattern, and it really did move opposite of what it looks like. It says x plus 3, but what it really did is it moved left 3. And then it followed the same pattern as before. Okay? All right. Try another one. No, I'm going to change that. Sorry. All right, sketch graph. Okay. I'm going to use the pattern. Back here we said that if, oh, I got rid of it, that the red graph was y equals x squared plus 3. We said that if there's a number outside of the x squared, it moves my graph up and down. So this minus 5 will move my graph down 5. Okay? Now remember, my pattern was over 1, up 1. It was over 2 and up 4 in both directions, right? Going from here, it goes over 1 and up 1, over 2 and up 4, over 3 and up 9 if I wanted to keep going. However far you go in the x direction, you square it, and you go that distance in the y direction. Why do I do that? Because it says y equals x squared. This is my parent function. This is a function that all of the other functions, this is my equation that all of the other equations, this is my graph that all of the other graphs will be based upon. So how is my new graph, whoops, y equals x squared minus 5 different than the original one? It's shifted down 5, but the shape is still over 1, up 1, over 2 and up 4, over 3 and up 9. And I'm always going back to the vertex. Over 1, up 1, over 2 and up 4, over 3 and up 9, from the bottom of the graph, which is called the vertex. Okay, let's try the other direction. Let me give you a graph. Give me the equation for that graph. Sorry, that's supposed to touch down there. Give me the equation for that graph. Okay, first question I have to ask myself. Is it moving left and right, or is it moving up and down? Well, obviously it's going left. Next question. Where do I put that? Does something go inside parentheses like that, or does something go out here? Does something inside here cause my graph to go left and right, or does something outside the square cause my graph to go left and right? Well, it's inside. Next question. Do I put x plus 4, or do I put x minus 4? Does that make my graph go left 4? No, that makes my graph go to the right 4. That makes my graph go left 4. Inside the squared makes your graph go left and right. Outside the square makes it go up and down. Inside, if it says plus 4, it really makes it go left 4. Outside, if it says plus 4, it really does make it go up 4. All right, let's try another one. Give me the equation. I'm going to give you a hard one. give me the equation of that graph. Find the equation for that graph. I'll give you a hint. You have something inside and you have something outside of the square. All right, let's do the easy one first. Outside, my original, I'll graph the original parent function. Looks like this, correct? Let's do it a little better. Looks like this. So what did we do with original y equals x squared? We moved it right 2, and we moved it up 3. What makes my parent function go right 2 and up 3? Right 2 minus 2, up 3 plus 3. Okay. I'm going to stop with that for right now. No, I don't. I got to do one more. Sorry, because the book does one more. What happens now if I stick a number in front of there? How does that affect my graph? Let's go back and make a table because we don't know. We haven't seen any of these yet. I'll use the exact same numbers for x just so we can make a comparison. So now I put -2 in for x. Order of operations says do the exponent first. So now this becomes 4 inside, and 2 times 4 is 8. Do not multiply first, you square it first. Put a -1 in. -1 times a -1 is a +1 times 2 is 2. Put in 0. 0 squared is 0 times 2 is still 0. And the pattern says it's going to do the exact same on the other side. So when x is 0 now, y is 0. When x is 1, y is up at 2. When x is 2, y is up at 8. And so I have this shape. And again, that's supposed to hit at 0, 0. Okay, so I have that shape now. Remember what we had before. It was 0, 0, then it went to 1, 1, then it went to 2, 4. How is my new graph different than the other one? Is it the same shape? Well, yeah, kind of. I mean, it's still a parabola, but it's steeper. It's not the same pattern of over 1 on the x and up 1. It's not over 1, up 1, and 2, 4. It's now over 1 and up 2. It's over 2 and up 8. My pattern is different. It's not the same as we had the first time. This here doubles all the y values. Didn't affect the x's. These are all the same still. It just doubled all the y values. Your turn. What does this do? Hopefully you say, oh, that's easy. It triples all the x values, or sorry, y values, right? So when x is a -2, y was 4, now it's 12. When x is a -1, y was 1, now it's 3. When x is 0, y was 0, now it's 0 still. 1, 3, 2, 12. So it's 0, 0, 1, 3. 2 off my graph at 12, and it's a really steep, those are supposed to be smooth curves, mine are really twisted. I gotta try that again. Okay, so it comes down, passes through there, and continues on up. Okay, numbers outside makes them steeper. Okay, last kind, we have absolute value. Now that we've got that covered, this should go a little faster. Y equals the absolute value of x. We don't know what it looks like. So guess what? We're going to make a table. If I put in the same numbers we had before, -2, -1, 1, and 2. -2, absolute value of a -2 is a +2. Absolute value of a negative 1 is a positive 1. Absolute value of 0, still 0. Absolute value of a positive doesn't do anything, so both of those stay the same. Graph it. When x is 0, y is 0. When x is 1 or a negative 1, y is 1. When x is 2 or a negative 2, y is 2. You should be able to guess. When x is 3 or a negative 3, y is 3. And it's a straight line. It is not a parabola. It is a V-looking shape instead of a U-looking shape. Okay? There's the absolute value. Your absolute value graph on an XY axis looks like a V. So we'll ask the same question then. What do you think this does to my absolute value graph? Think about what we just did with the quadratic. I'll graph this one in blue. What I noticed is before, everything outside moves my graph up and down, exactly what it says. So plus 3 will move this graph up 3. But it'll maintain the same shape, over 1, up 1, in both directions. Over 2 and up 2 in both directions. And so I get the V-looking shape, simply moved up 3. Same graph, moved up 3. What does this look like? Again, push pause whenever you want to, if you don't want me to tell you the answer right away. If I think back to the quadratic, inside the squared moves it left and right, opposite of what I would think, or opposite of what it says there. That says, kind of looks like it says x minus 2, but it really goes to the right 2. And it goes over 1, up 1, over 2, and up 2. And I get the same shape as my parent function, simply moved over 2. All right, let's go the other direction. Give me the equation for this guy here. What's the equation for that guy? I know its absolute value. I know it's shifted to the right 3. And I know it's shifted up 2. Done. When I say it, what do I mean? I mean the parent function. This original graph we had has been shifted right 3 and up 2. Sorry. Okay, it's been shifted right 3. My computer's freaking out. Right 3 and up 2. How do I do that in an equation? I put plus 3 or minus 3 inside and plus 2 on the outside. All right. Give those a try. I think that's good for right now.